Hi guys, BuildZoid here, and today we're going to be taking a look at the Asrock Z690 Phantom Gaming Velocita PCB. So the PCB pictures were sent in by a viewer of the channel, so big thank you to them for sending over the pictures. Yeah, at the time of shooting this video, the board tends to go for around $470 US, which makes it a rather expensive Z690 motherboard, especially considering the feature set that it comes with. It's not great. So anyway, let's get into it. Starting off with the rear I/O, which, you know, if it wasn't for the fact that the board costs what it does, I would actually kind of like this. So we get a ton of USB Type A ports, right? Like you get all of that and all this, and so obviously I'm a fan of that. You also get 1 gig and 2.5 gig Intel LAN, though I'm not sure which is which. So one of those is 1 gig, the other is 2.5 gig. And this is one of those sort of weird ones where it's like in this price range from like MSI, you can get dual LAN. I think Asus has a motherboard with like 10 gig in this price range. Gigabyte has a motherboard with 10 gig in this price range. So this is like from a network, like in terms of networking connectivity, this board is just worse than everything else in this price range. So yeah, I'm not sure like why they even bothered with the second networking controller, because yeah, but like I feel like it would have been better if they had just ditched that and made the board cheaper or something, because as it is, it's like Asus has better boards, like for connectivity, like Asus, Gigabyte, MSI all have better boards in this price range than this. Anyway, for the audio section, we've got, you know, the usual set of audio ports. They light up, which I guess will maybe make them easier to find in the dark, if, you know, you're doing that. So that's not completely useless, I guess. You also get an optical out. There's a USB Type-C port in the back. You get Wi-Fi 6E from Intel, and you also get a BIOS flashback button, so you can update the BIOS of the motherboard without even having a compatible CPU. This can also sometimes recover from like corrupted BIOS flashes, but that's not its intended function. You also get a HDMI and DisplayPort output on the rear I/O. So yeah, like I said, basically, like this would be great rear I/O if the board was like less than $400 in my opinion, because at around $470, like I think the Master goes for like $450, and that has 10 gig on it. There's the Asus has that like Pro Art Creator board, which is also somewhere in this price range. That has 10 gig and like Thunderbolt. Gigabyte has the Aero D, which I still don't know what the price for that board is yet, but that exists, should be somewhere in this price range, 10 gig Thunderbolt. Yeah, MSI, I think, has dual 2.5 gig LAN on the Unify, and off the top of my head, I want to say that board's $450. So this right here is like, yeah, this would be good if this was like a mid-range motherboard, not a high-end one. So, yeah, anyway, moving on to internal connectors, and this is where I arguably gets worse. You get technically you get 4 M.2 slots. You get this one, which is connected directly to the CPU, and that runs at Gen 4 by 4. You get this one, which connects to the chipset, and I believe runs at Gen 4 by 4. This one, which also connects to the chipset, and I think is also Gen 4 by 4. And then you get this one, which is labeled Blazing M.2. And honestly, this is probably like this is the part of the board that I like the least, because what this is, and the reason why it's called the Blazing M.2, is that's a Gen 5 M.2 slot. And you might be wondering, how the hell did they get one of those? Because there's no dedicated PCIe lanes for a Gen 5 M.2 slot anywhere in the system. The chipset doesn't have them, the CPU doesn't have them. How did they get a Gen 5 M.2 slot? Well, that's very simple. They steal PCIe lanes from your GPU so that you can get an M.2 slot that runs at X4. You know, and the thing is, like, so I dislike this for, like, 2 reasons. One, M.2 slots are just inferior connectors to PCIe slots, okay? You can convert a PCIe X8 slot into a M.2 X4 or whatever other connector type you want. You could have 10 gig LAN on it. You could have Thunderbolt. You could have, you know, you could have some crazy adapter card that breaks out into multiple M.2 slots. Those actually exist with like a built-in PC. Very expensive, but they do exist. And instead, what Asrock has decided to do here is they take 8 of the PCIe lanes from your GPU, because, well, actually, they're not taking 8 of them, but because of how PCIe works, you can't have an X12 slot. That's not a thing. So they take X4, right, with these two PCIe Gen 5 switches, which, by the way, are very expensive. These are probably one of the main reasons this motherboard is $470 is these two chips right here. Incidentally, a lot of the other motherboards in this price range also have these Gen 5 PCIe switches, but, you know, you'd expect that in this price range. Anyway, so they take X4 with these Gen 5 switches, and they shove it over here, and your GPU gets left running at X8. Isn't that great? And also, you can't convert from X4 back to X8, whereas if they just did the sensible thing, and admittedly they would need another, you know, 2 PCIe Gen 5 switches if they did the sensible thing, but I'd argue, like, honestly, there's no reason that the board should be more expensive than 4. Like, even if they had 4 of the damn switches, the board still shouldn't be more than $470. The MSI Z690 Carbon has dual X8 support for the CPU. That's a $400 board, if I remember correctly. So this being $470 has no excuse for having half as many Gen 5 switches and then costing more. So anyway, the more sensible thing to do would have been to just, you know, have X8 sent off to this PCIe slot over here, and then if you really wanted to convert that into a Gen 5 SSD, you could just buy an adapter card to get your Gen 5 SSD onto the X8 slot. And maybe if you don't want a Gen 5 SSD, you can use that X8 slot for useful things, like literally any other card. But yeah, so this right here, this is actually horrible in my opinion. This is completely stupid. This is the main reason I don't like this board, is this right here, because you are taking a, you know, basically infinitely flexible connector, like a PCIe slot, and you're converting it into this horrible, you know, and converting it into this horrible thing over here, which only takes SSDs and Wi-Fi cards. Doesn't take Thunderbolt cards, doesn't take network, like, doesn't take, you know, 10 gig LAN cards, that kind of thing. Doesn't do those. Only SSDs and Wi-Fi. Lovely. Exactly what we need Gen 5 for. Anyway, so yeah, I think that's like super uber dumb. This right here. This is just terrible as far as I'm concerned. Anyway, also, yeah, that does mean your primary PCIe slot drops to X8 if you put 4M.2 SSDs on this motherboard, which, fun fact, even some of the cheapest Z690 motherboards will not sacrifice your, you know, GPU to X8 mode by populating all the M.2 slots, because on Z690, the chipset has plenty of PCIe lanes for like 4 M.2 slots connected directly to the chipset. Admittedly, I think the fourth one in that scenario ends up running Gen 3, but you can, okay, so yeah, the fourth slot I think ends up being Gen 3, but you can have 3 Gen 4 by 4 M.2 slots connected directly to the chipset. So doing this, like, this is the kind of thing I'd expect to see on like a B550 motherboard, not a Z690. Like, there's plenty of PCIe lanes to go around from the chipset, from the CPU. Why? This is a stupid gimmick. Also, if they just didn't do any of this, they could have just had a cheaper board, which would have made it slightly more competitive, because as it is, you have this useless gimmick on here and a really high price tag. Like, great, amazing, truly incredible. Exactly what we need on motherboards. Anyway, so other than that, you do get a, you know, like your primary X16/X8 slot, which, again, that M.2 slot converts it to to X8. We have this open-ended PCIe X1 slot that you'll never be able to actually use if you ever use a GPU, because it's rammed right up against that GPU slot. So I'm not entirely sure why this is here. Like, there's nothing particularly wrong with this. It's not stealing lanes from anywhere, but, like, I do have to wonder if Asrock knows what a GPU looks like, because, yeah, there's no way you're plugging that thing in. Then you get an X4 off of the chipset, an X1 off of the chipset, and a X2, if I remember correctly. So, yeah, basically you have the same kind of connectivity that you would find on, like... Actually, this is arguably worse than a $200 Z690 motherboard. So, yeah, I'm really not impressed by this right here, because this is just dumb. Like, why are you misusing PCIe lanes like that? Anyway, other than that, you do get 6 SATA ports. There's a clear CMOS button over here. There's a postcode in a location that I'm generally not a fan of, because if you put it, well, like, at least they didn't stick it like over here where the GPU would cover it up, but like, as far as I'm concerned, the postcode belongs in the top right corner of the motherboard, not the bottom right corner, but like it's not the worst position. Like there are motherboards where you'll have your postcode like here, which is extra dumb. So this is pretty bad, but it's not the worst. Yeah, anyway, you also get an internal Type-C connector, you get a USB 3.0 over there, you get a 24-pin, which just sticks straight up. This is an ATX motherboard, it's not EATX, but yeah, that's like EATX boards still aren't. Well, actually, Gigabyte has sort of really increased the number of EATX motherboards that they make. Like, there's a surprising number of EATX Gigabyte boards these days. Usually there's only like one EATX board. Now I think Gigabyte has 3 of them. Anyway, but this is still ATX. Then we've got a power button and a reset button over here. So, you know, like I do appreciate these for test bench use. So that's nice, but other than that, like this whole part of the board is a disaster as far as, okay, that's not true. Like this part. Terrible. Because to be fair, like this is actually pretty normal for most Z690 motherboards, but I mean, this is pretty normal for Z690 motherboards that cost less than $400. So in this price range, this isn't normal. Actually, I think the Gigabyte Z690 Master is kind of similar to this, but that board still isn't stealing your lanes for an M.2 slot that you're not going to be, like, that I don't think you should be using. Anyway, and also, I don't particularly like the PCIe connectivity of the Z690 Master either. So comparing this board to that board isn't really, like, not really a great, like, I don't feel like I'd want to be compared to the Z690 Master for connectivity, because that's not what that board is about. Anyway, let's move on to the power delivery, which it's not incredible, but it is interesting. Asrock has a really, really unique, and I am over-highlighting it because of it. Asrock has a really, really unique approach to their VRMs, at least on the input filtering side, which we'll get to after we talk about the power stages and the controllers. Anyway, so down here we've got the VCC in rail. Then we've got a whole lot of vCore, which ends over here. So we've got vCore. Do I want to put that there? Yeah, I think. No, we can put it into there. So that's all vCore. And then over here we have the iGPU phase. So you got single phase iGPU. So I'm just going to put 1 phase. VCC in is 2 phases. And then the vCore is actually 16 phases. And we're going to squeeze that over here. So you get 16 phase vCore. All of the phases are real because we've got the incredible Renesas RAA 22. Well, actually, there's 2 controllers for this because this only does 2 outputs, which we obviously have 3 different rails here with the VCC in, but we'll get to that. So RAA 229131, which is a 19-phase VR, like, yeah, that's a 19-phase controller. And so that's just running in 6+1 phase mode here. Right, the +1 being the iGPU and the 16 being the vCore, so we don't need any doublers or putting power stages in parallel or any weirdness like that. And then for the VCC in, the controller is another RAA Renesas chip, which is actually pretty unique because most of the other manufacturers are using monolithic power systems for VCC in, at least like Gigabyte and MSI are. I actually don't know what Asus is using. I haven't checked yet. No, I think, well, the low-end Asus board doesn't use monolithic power systems, but the higher-end Asus boards, I'm not sure. I've not checked. Anyway, so this is an RAA 229001. And I forgot to check how many phases that can go up to. I want to say this is an 8-phase controller. And I wouldn't be too surprised if it actually was. It's got an awful lot of pins for just a 2-phase chip. Also, I feel like this was the vCore chip for a bunch of like B550 motherboards, but yeah, I didn't put that in my notes. So yeah. Anyway, if anybody cares to actually look up how many phases that controller supports, then you're free to do that. Leave it in the comments. Anyway, let's talk about the. Let's go back to the vCore because that's like the actually important power rail. So yeah, the control scheme, nothing really weird going on with that. Then for the power stages themselves, we've got a bunch of, and actually this, Asrock uses these everywhere, so they really do have a simpler VRM design than some of the other manufacturers here in terms of component selection, because you'll see like, Well, usually if you have them a monolithic power systems VCCN controller, you'll also have monolithic power systems power stages, whereas this VRM, every single, like VCCN, VCore, Igpu, all of the power stages here are ISL 99360s, which are 60 amp smart power stages. And nominally, these are not impressive on paper, or more like, well, no, they're not impressive by name. And the reason I point that out is because a lot of the motherboards in this price range use like 75 amp power stages, or 105 amp power stages, or 90 amp power stages. Luckily for Asrock, that doesn't really mean much of anything. Because basically once you go past 60 amp, like with power stages, once the nominal current rating is higher than 60 amps, a lot of them perform exactly the same. Like I think for Intersil, they have 60 amp parts, 70 amp parts, 80 amp parts. Actually, I don't think they have any 80 amp parts, 90 amp parts. And Intersil is now owned by Renesas, so I'm including like the Renesas parts. Even like the 105 amp parts, they all perform basically the same. And I'm like, they actually do perform basically the same. The high current ratings, I think, might be more to do with the current sensing functionality, or maybe like instantaneous current capabilities, because sustained load, the 60 amp parts perform, like according to the documentation, the 60 amp parts perform exactly the same as like 90 amp parts. The only exception to this that I'm aware of is Infineon, who, like, Infineon makes 90 amp power stages that are actually better than their 70 amp power stages. But their 70 amp power stages perform basically the same as their 60 amp parts, so, you know, that's fun. Yeah, so basically the point here is this nominal current rating doesn't really mean much of anything. And it also helps that the 12th gen CPUs pull less power than their predecessors, so you don't even need that much power delivery in the first place. Anyway, so let's talk about the theoretical efficiency of this VRM, which is more actually affected by the, like, there are other, like, the other thing to consider is that this board, yes, it uses 60 amp smart power stages, but the actual bigger weakness of this board compared to other $400 to $500 motherboards in terms of VRM efficiency at really high current outputs is the relatively low phase count. Like, for comparison, the Z690 Master has 19 phase V-core. I think MSI is doing like an 18 phase on the Carbon. And I think 19 phase, yeah, the Unify boards are 19 phase V-core. So, like, this is still slightly less efficient. And also it'll run hotter because the heat is spread across less components, though. I'm pretty sure Asrock is using a cheater fan on the VRM heatsink of this board, so, you know, like, that doesn't really matter anyway, but, yeah, this is actually slightly weaker on efficiency, but it's not because of the weaker, like, the lower current rating power stages, it's because there's slightly fewer of them. Anyway, so at 1.2 volts output voltage and 500 kilohertz switching frequency, this VRM is going to be capable of powering any CPU you can fit into the socket without any issues, because 12th gen doesn't pull that much current. So 200 amps output to 300 amps. So 200 amps output, the VRM should produce about 16 watts of heat, which is slightly worse, very slightly worse than some of the other motherboards in this price range. I think the best performance for 200 amps output that I'm aware of off the top of my head is like 14, 15 watts of heat. So this certainly is not a bad result by any means. It'll power like 200 amps load. This VRM should have no issues with that whatsoever. In fact, you could probably run this VRM without a heatsink and it still wouldn't overheat, because at 16 watts for the entire VRM, you would be looking at about a watt per power stage. The board does use an 8-layer PCB. Yeah, I'd like, you know, the thing is, like, Z690, most of the Z690 motherboards are very, very overkill. 300 amps output, we're looking at about 26 watts of heat, so now the VRM heatsink stops being optional, but you'll also be happy to know that pulling 300 amps of current on a 12th gen CPU is incredibly difficult to do. Mostly because the CPUs become completely uncoolable at those kind of current draws. And so while this is, like, if you have a really, really, really good cooling system, you might be able to hit this sometimes, maybe. Not really. Under like normal circumstances, you should really never be hitting 300 amps. Like this is, yeah, like for normal 12th gen usage, this like, and when I say normal 12th gen usage, I do include like custom water cooling loop, you know, potentially even liquid metal on top of the IHS. Like, good luck hitting 300 amps of current draw because the chip is going to be super insanely hot. Anyway, 400 amps of current, which is, you know, more like now we're going into sort of theoretical and LN2 overclocking territory. At 400 amps of current, this VRM would produce about 36 watts of heat, which, yeah, that's a good result for this much output current. The thing is, like, you're never going to hit this unless you're doing like LN2 overclocking, and then 500 amps output. The VRM will, man, I wanted to get rid of that circle there, but too late. I have to undo too many operations. Anyway, 500 amps output, it'll produce about 53 watts of heat, which is, you know, like, which is still coolable. Like, if Intel ever made a CPU that was capable of pulling 500 amps and on the LGA 1700 socket, like, this board could power that. Like, at this point, you would really need airflow, and the fan that the VRM heatsink comes with would actually become useful. But, yeah, like, so typical, you know, typical high-end Z690 motherboard VRM, incredible overkill. For any CPU that you can actually fit into the LGA 1700 socket. Like, this really wouldn't look out of place on a Threadripper motherboard. Anyway, so that's the V-Core. The iGPU uses, as I mentioned earlier, the same smart power, 60 amp smart power stage. I don't care about the iGPU power. VCC-in is 2 phases of, you know, more 60 amp smart power stages, so the VCC-in is also extremely overkill. You know, like VCC-in, you're not going to see it pushing 40 amps ever. But if you somehow manage to get the VCC-in rail to pull 40 amps, the VRM would only produce about 4 watts of heat, which means, yeah, like the VRM like the operating temperature of the VCC-in is going to be more affected by the temperature of the, like, how hard the V-Core VRM is working than how much load is on the VCC-in itself. So that's kind of that for the actual power stages here. And so while, you know, nominally this VRM looks really weak compared to a lot of the other motherboards in this price range, performance-wise is actually completely fine. Like, my problem with this motherboard isn't the VRM. No, my problem with the motherboard is this stupid-ass M.2 slot over here. This just, no. Don't do this. This is bad. I like PCIe lanes. I don't like SSD connectors. Anyway, so, yeah, so the VRM on this, like, it doesn't sound as impressive as, like, the 105 amp smart power stage VRMs from the likes of Gigabyte and MSI and Asus and, like, literally everybody else, but at the same time, this will perform just fine. Like, this isn't going to have any issues powering any CPU that you can put into the socket. So, yeah, that's kind of that. Now, let's get on to the part that I find really interesting about this VRM, which is the input filtering. Asrock has a really, really unique approach to input filtering capacitors. So on most motherboards, right after the power connectors, you would find a input filtering inductor, which basically exists to block the switching noise and the transients from the V-Core VRM from, you know, going to your power supply. Now, Asrock doesn't have this inductor, like, at all. It's just not there. Which is really, like, it's interesting that they've ditched it, because I'm not sure if it's a cost thing. I don't think it is, because the input filter on this motherboard is actually very substantial and quite expensive for, you know, motherboards in this price range. And so I have to assume it has something to do with efficiency. Because admittedly, like, if you do have that input filtering inductor, like, that inductor has some amount of resistance, which is going to be, you know, means it's going to produce heat. Potentially that input filtering inductor can also be a source of coil whine, right? Depending on, like, how much, like, it could create coil whine. I'm not sure that that's necessarily a common thing that actually happens on motherboards. It's always really hard to figure out which inductor is actually making coil whine whenever you run into that. Though in my, like, though input filtering inductors, I feel like, are in some ways more susceptible to it than output filtering inductors, than the actual output inductors. So yeah, like that's really interesting that Asrock doesn't have the input filtering inductor, because that's normally like a component that you see removed on like uber cheap motherboards where the cost of a couple cent inductor is like no longer acceptable because the motherboard has to cost $50, and any extra components have to be removed because the board has to be as cheap as possible. But this is a high-end board, or at least it's not a cheap board. And so the missing inductor is kind of like an interesting thing. And Asrock just kind of does this on their boards. Now, obviously, this would mean without that input filtering inductor, you're going to be sending more switching noise to the power supply potentially. And so I guess to sort of compensate for the lack of like blocking the VRM noise from reaching the power supply, Asrock has a lot more input filtering capacitors than you see on a lot of other motherboards. We've got 6 tantalum polymer capacitors, sitting sort of evenly spaced around the vCore and iGPU VRM. And these seem to be 150 microfarads, which is quite a lot of capacitance for tantalums. And then we've got these 3, 16 volt, these are probably 16 volts as well because they're on the 12 volt power plane and they don't make that many different voltage flavors of capacitors. So anyway, then you've also got these 270 microfarad through-hole polymers over here. And then if we look at the back of the board, we just sort of get the usual multi-layer ceramics for the input filtering that sit right behind every single power stage. So basically, there's there's no input filtering inductor, but seemingly to compensate for that, Asrock uses a lot more input filtering capacitance. So that is one of those things that I've always found really interesting with Asrock boards, is just yeah, that's unique. You don't see that from most other manufacturers. Though you do sometimes see there are quite a few boards where you'll have really substantial input filters, but they'll still have the input filtering inductor. And so I do wonder if the leaving out of the input filtering inductor is meant to help with maybe it might help with slightly with transient response. It might make the VRM, you might lose less power on the way to the power stages. Yeah, I'm not sure, but it's just an interesting thing that Asrock does. And what's also interesting is so they don't have an input filtering inductor for the high power draw vCore VRM, but then the VCC-in gets this adorable little thing over here, right? This 680 nanohenry little inductor, and then its own little input filtering capacitor bank, which is extremely overkill. This right here is insane. This is what, 450 microfarads of tantalum polymers just dedicated to VCC-in. So, and basically somewhat isolated from the vCore VRM, which you just don't see on most other motherboards. Most other motherboards will have one input filtering inductor, and then everything runs off of the same 12 volt power plane. So, yeah, I do kind of wonder if there's any actual power delivery benefits to this, really lots of capacitance approach of the input filter that Asrock has here. At the same time, I wouldn't be too surprised if this actually did nothing. The thing is with motherboards, past a certain point, it's relatively easy to hit diminishing returns, and past that point, more anything doesn't really make a difference. And I just hit the mic, so sorry for that. Yeah, and so I'm kind of wondering if this board isn't well into that territory of just even if you removed all of this, the performance might still be completely fine. Though they definitely don't hurt anything by being there. So anyway, now let's talk about the output filtering, which is a lot less interesting. The input filter is definitely a very Asrock thing. The output filter, we've just got our standard through-hole polymers. These are 560 microfarads. It is worth noting that the Nippon Chemicon, no, these aren't Nippon Chemicons, these are Nichicons. So these are Nichicon FP12K capacitors. So Asrock basically has 12,000 hour rated capacitors, whereas everybody else uses 10,000 hour rated capacitors. Honestly, it doesn't really make a difference. It's just kind of interesting that Asrock, these are a special Asrock capacitor flavor, because nobody else uses them as far as I know. And yeah, there's not really any benefit to those, though. If any, and there's also not really much, you can't even really buy these, which is kind of interesting. You can buy 10,000 hour rated capacitors quite easily. the 12,000s do really seem to be some kind of special Asrock flavor. Anyway, 560 microfarads and 6.3 volts, pretty standard voltage and capacitance rating. And we do have a lot of them here, right? Like, I think we have, what, like 2 or 3 for the iGPU, and then for vCore we have all of this, and then all of that. Or maybe all, well, I'm not, probably all of this, like that. So we do have quite a lot of bulk capacitance on the output of this VRM. I'm not sure about the inductance of the inductors on well, anything here. These might be 300s. They kind of look like 300s to me. Because the low inductance inductors tend to... the low inductance inductors tend to be kind of obvious in that they don't really look very inductory. The lower the inductance inductors are, the more they become basically a piece of wire. And yeah, these don't look like the usual 150 nanohenry inductors that you see from some other vendors. These could still be 220s, I guess, or something in that range. But yeah, they don't look super low inductance. Anyway, on the back of the board, we can see Asrock taking a leaf out of Gigabyte's book and slapping tantalum polymers into the CPU socket. And this would, and the thing is, this doesn't really seem to achieve... Well, this falls into very much the territory of diminishing returns. Let's just put it this way. I've tested a bunch of the Z690 Gigabyte boards I have with the oscilloscope. I can't measure a difference between any of them. Like, at all. My oscilloscope is just, like, either my oscilloscope is not sensitive enough, or there isn't a difference past a certain point. And this is... So... You know, assuming that there isn't anything massively wrong with the programming of the voltage controller, in terms of the filtering that we have here, I imagine this would be comparable to any other high-end Z690 motherboard. So, yeah. So this is neat. Like, I still think it's cool to have the tantalum polymers in the CPU socket, but they're not really... I don't think that they're actually necessary. Yeah, because I have a whole lot of test data that shows that I have boards which are mostly ceramic in the socket versus boards that have a lot of tantalums, and the measurements are the same. So yeah, so I'd assume this falls into that same territory of it's very good transient response still. It's just the tantalums don't necessarily make much of a difference. But yeah, they don't hurt anything by being there. So that's kind of that. And so that's basically all of the CPU power delivery, isn't it? Like, we've got honestly, there's nothing wrong with this VRM. Yes, nominally the current rating's kind of low, but the output filtering looks good to me, right? Like, the output filtering looks good to me. We've got our slow through-hole polymers right on the output of the VRM. Then we've got some tantalums and ceramics mixed into the socket. The input filter is actually very substantial compared to what you see on a lot of other motherboards just in general. Right? Not many motherboards go all the way with like tantalums hanging out right by the power stages. And yeah, so like... The thing is, like, I feel like if this board was just cheaper, because I like the I rather like the VRM on here. This is a very, sensible VRM for an LGA 1700 motherboard. It's just that the board's freaking expensive. And that. Anyway, let's move on to the memory, shall we? So, as I mentioned earlier, the board does use an 8-layer PCB. And like basically every Z690 motherboard with 4 DIMM slots, it uses a daisy chain topology. And it is, shielded, though, or at least I assume it's shielded. The thing is, so, I'm not sure if it's fair to call it a shielded topology, because I guess this is a kind of shielding, maybe. I'm not sure. Anyway, Asrock does this really weird, checkerboard pattern over their memory traces. So like this section of the memory right here, that's the command address bus, and that just runs on the top layer of I think every single Z690 motherboard there is. And that's because this doesn't require the same level of or actually I believe this might actually require not being referenced against a ground plane or something. So I'm not sure what the specifics are for this always being on the top layer of the board, but all of your data lines, those are in like these areas of the of the motherboard, and yeah, you can't see any of the data traces because they're buried inside the actual board itself. And yeah, you can really... Yeah, Asrock just does this, like, instead of having... So, for comparison, on a Gigabyte motherboard, where Asrock has, this checkerboard pattern, Gigabyte would just have a ground fill. And the same is true of, like, MSI boards and Asus boards. And yeah, I'm not sure that there's any benefit to this. I'm honestly not really sure what it's even called. It's a thing that Asrock does. And, man, GIMP is being weird. I think I broke it. Yup. Anyway, oh, it's back to normal now. Yeah, so this is a thing that Asrock does. Not sure what it achieves. You can see more of the command address bus over here. But yeah, all of the actual data lines are all on internal layers of the motherboard, so I guess it would be fair to call it a shielded daisy chain topology. And damn it, I'm on the layer selection. Anyway, so I guess it would be fair to still call it a shielded 8-layer daisy chain topology, though it is, Asrock is definitely doing something pretty different from what you see on most of the other motherboards out there. Anyway, since it's a shielded daisy chain topology, you should only ever use these 2 DIMM slots if you like your memory clocks not being freaking terrible. Yeah, like, technically these 2 DIMM slots do exist if you absolutely need them, absolutely desperately need the extra memory capacity. However, I would recommend that, like, before you go, like, because it's a daisy chain board, 2x32 is going to be significantly better than 4x... Like, this board favors any 2 DIMM configuration, right? It's going to prefer 2x16, 2x32, and I imagine DDR5 will eventually hit 2x64 DIMMs as well. In fact, we're probably going to see 2x48 DIMMs sometime in the next couple years, as SK Hynix is making like 24 gigabit DDR5 memory chips, which, yeah, those are going to be wacky, but... Yeah, so because it's a daisy chain motherboard, you should probably just never use these extra DIMM slots, because when you use them, especially with DDR5, it absolutely tanks the memory speeds. And yeah, that's kind of that. Like, it's to the point that if you need the extra memory capacity, in my opinion, you should really be considering DDR4, because 128 gigs of DDR4 will actually run at comparable speeds to 128 gigs of DDR5 at this point. I don't know, maybe in the future we'll have CPUs with memory controllers that can deal with very large quantities of DDR5, but currently we don't. And so I'm really confused why motherboard manufacturers even bother with daisy chain topologies on DDR5 motherboards, because it's like, this is what isn't going to work. Like, it's not really going to work if you actually use all the DIMM slots. Though I guess if you're fine with running your memory at JEDEC speed. But the thing is, it's a high-end motherboard. Why are you buying a high-end motherboard and then running your memory at stock? So, yeah. Well, actually, fun fact, four sticks of DDR5 at 4800 megabits per second is actually violating the Intel specifications for 12th gen CPUs. So that's technically an overclock. If you run 4800 CL40, that is technically an overclock for 12th gen CPUs if you use 4 memory sticks to do that. Anyway, so that is the Velocita, and oh, I guess I should mention, I don't actually know how well this board clocks compared to the other 8-layer daisy chain boards. Yeah, so... And I'm not willing to take the manufacturer, like, memory speed advertising from really anyone for DDR5, because my experience with DDR5 so far has been that at the higher, like, as you approach the limits of what the motherboard is able to do, it's not that you can't pass a memory stress test, it's just really inconsistent, reboot to reboot. It's kind of like how Ryzen had a really hard time with, like, you get your memory overclock all good and steady, and then you cold boot the system, and suddenly nothing works. Well, actually, what Ryzen would do is it would fail to train. 12th gen is worse, because it'll get you all the way back into the OS, and then it'll be unstable. Yeah, so that's just DDR5 things. hopefully that eventually gets sorted, but I doubt it because Z590 was already doing this. Like in Gear 2, the 11th gen memory controller already did the thing that like DDR5 does, where you can have an overclock, reboot, and then it's not stable anymore. So, yeah, and as far as I know, Z590 never fixed that, so I'm guessing Z690 is just going to live with that forever. It might just be a side effect of the Gear 2 memory controller mode. So, yeah, anyway, that's the Z690 Velocita. It's really overpriced. It's not a bad board, but at $470, I think Asrock is absolutely insane. Oh, I guess we also have an external... is that... Actually, that does look a hell of a lot like an external clock gen. So this might do non-K overclocking. Might. But that sure does look like an external clock gen to me. It's in the right location for that. Yeah. So it does look like you have an external clock gen on here, so you might be... It'll do non-K overclocking, so you can, you know, buy your $470 motherboard and stick... I guess you could get a non-K 12900, right? And like overclock that. I don't know really why you'd want to do it that way, but you could. So, also, I don't believe Asrock has released a non-KOC BIOS for this board yet, but they could. And hopefully they do, because, yeah, even though I do think this overall is kind of, like, it would make the motherboard suck slightly less, you know? Just give it more features, because currently, that's definitely not a strong point of this board. Anyway, yeah, that's it for the video. So that's the Asrock Z690 Phantom Gaming Velocita. And thanks to the viewer who sent the pictures in, because yeah, without them we wouldn't have this video. And that's it. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it'd be much appreciated if you'd check them out. And that's it for the video, so thank you for watching, and goodbye.